How's it going, everybody? We're going to sit down and solve question number 252, meeting rooms. We're going to read the question, understand it, and then I'm going to walk you through how you can effectively come up with a solution. Go step by step. I'm not just going to jump into a solution. That's not what this channel is all about. I want to show you how we come up with a solution. Okay? Stay tuned. All right, let's read the question. Given an array of meeting time intervals consisting of start and end times, where S1 represents E1, or S1 is the start time, E1 is the end time of the first variable, and so on and so forth, determine if a person could attend all meetings. Now, some of this, sometimes, people might be scared of looking at like these, symbols, and it's algebraic symbols, but effectively all it's really telling you is like, you're going to be getting an array of tuples, right? Where, for those who don't know what tuples are, they're just basically things that have two elements on it, right? So you're given an array of arrays, and what you're trying to do is to see whether or not you can attend all these meetings, right? Where within that secondary array, the first value is when you start, and the last value is when you end, right? So another way to paraphrase this question is think about it as if you were to go to a conference, right? And you're given basically 3 time slots, right? And those 3 time slots, you're gonna be asked the question, hey, can you attend all 3 conferences, right? As a person, what would you do? Well, I won't really answer that question. I'll probably have to see if anything's overlap, right? So effectively, this question has been turned around a little bit, and just we have to think about, okay, how can we find any of these overlapping instances, right? Because the minute it overlaps, that means we already answered the question, which is no, I cannot attend all meetings, right? I can only attend, say, 2 if I have 1 overlap, if you're given 3 time slots, right? So on this question, we have to come up and just think about, okay, how can we find overlapping elements giving these ranges, right? Don't think about time, just think about like a little range, So let's look at an example, right? The 2 examples that they give us. So the first example they give us is like from the range of 0 to 30, right? From 0 to 30, that's cool. That will set a little bar for us, right? We could say like, okay, we start from 0 and we end at 30, right? And then we look at the next element, right? So intuitively, or very brute forcey, how would you solve this, right? A way to solve it is potentially compare the 2 elements, right? We're gonna see like, okay, the next element here is a 5 to 10, the range, right? In this case, 5 to 10 is within the 0 to 30 range, right? So therefore, by knowing that, I already know that I can't attend all the meetings. I can just return false and get out right away, right? Let's look at the second case, which is 7, 10, and 2 and 4. All right, so in this case, we have to ask, okay, well, my range is starting from 7 to 10, right? And my next element is going to be from 2 to 4. Well, from 7 to 10 and 2 to 4, they don't overlap one another, right? If you think about it on a ruler or something like that. So in this case, I can't attend all 2 meetings, right? So in this instance, you're thinking about, okay, what can I do to solve this type of problem? I mean, I can intuitively think of a solution, but how do I actually solve it, right? So instead of like when we think about the algorithm earlier, we're effectively comparing the 2 start times and the 2 end times. But that's kind of troublesome, right? If you wanted to compare the 2 start times and 2 end times for every single element, right? So maybe in these type of questions, we have to think about, all right, so because there's basically 2 things you could do to a question, right? You could A, use the existing data structure, right? Or B, you could manipulate the existing data structure, right? And then you could apply a certain custom algorithm, right? Well, don't be scared by algorithm. Algorithm is effectively just 1 plus 1 can be an algorithm. It's just a something to solve the problem, right? And the data structure is literally just how you store things, right? It's funny how this industry comes up with like fancy words for some simple stuff like that. But back to the question. So what can we do to arrays that we know that can help us so we don't have to always compare your start and end elements for every single element? Think about it, right? So what we can do, we can't assume when things come in it's all in the right order, right? Order can help us solve some of these questions. So when you think about it, all we're really concerned if things are, for example, if they were sorted, by the start times, then effectively all we have to worry about is whether or not our end times will ever overlap the next, start time. That's pretty much it, right? So by sorting things, you already have that attribute, like your first element is always going to be of lesser or equal to the previous element, right? That's one of the key things of sorting. By knowing this key attribute, then all we need to do right now is just maintain where my current end time is. And then when I look at my next element, just compare to see if my next element's start time crosses. And that's it, right? So this seems like a relatively simple problem. So let's try solving this. First of all, I'm going to adjust this a little bit because I like writing my functions this way. Cool. So before we jump into any question too, we have to ask ourselves, are there any special notes here given to us? Are there any assumptions given to us? There's none, right? So you can't assume the input array is sorted. And you can't assume the input array is also perfect either, right? So what I like to do sometimes in an actual interview is ask the question, the interviewer, hey, can I get an empty array? Or hey, can I get something with just only one slot? If that is the case, I'm gonna code it here. If intervals dot length is less than 2 elements, right? I'm gonna return true as a default. So if I have one slot, I'm assuming that I could go to it. Even if it has nothing, I'm assuming that, yeah, I can go to nothing. That's perfectly valid, right? So what's the next thing we have to do? So next thing we have to do is intervals dot sort, right? And you want it to sort the elements here. Whoops. Okay, sort. Okay, return. And you're gonna go your A element, okay, minus my B at position 0. When you say A at position 0, that refers to this element, right? Your starting point. Okay. For those who don't know the sorting function, I highly recommend just Google it and you'll find out why this works the way it does. But that pretty much gives us from ascending order. Great. Now we have that's cool. Now the next thing to do is to keep track of our end times, right? So let n equal to interval dot at the first one. We're gonna say hard code this into okay, your first element, because we already captured a edge case of if it's only one element. Then we already return out of it, so we can actually do this particular phrase, which is I'm just gonna assign my first end interval to be the first element's end interval, right? Simple enough. And then now all I need to do is write di equals to now the first element, right? Or the second element. It's gonna be less than intervals dot length, right? And I'm gonna be I plus plus. All right, so we're gonna go through it and do stuff to it, right? All we have to really check is if my end is, greater than intervals at my current position, and my start time, right? Is my end gonna be greater than my start? If it is, then just return false, right? And if it doesn't, well, end is less than intervals at I at 1. So I'm going to check whether or not my current end interval is less than the next new end interval. If it's less, then we probably should update that number, right? And keep the maximum of it. So interval at I and 1. All right, cool. Otherwise, all we need to do is return true, right? And that should solve our problem. So let's submit it and check it out. Great, we got 90%, not bad. So yeah, that's pretty much it. That solves the problem. If you like these type of questions, I go through it as much as I can. Next video is going to be the next harder version of this problem. And then by doing this first question first, I think it'll be very helpful to move to the next one. Okay? Stay tuned. If you like this, please hit the subscribe button and the bell so you get notified when the next video is updated. And I hope you guys have a great time LeetCoding. See ya.